A really important topic in pre-calculus is something called unit circle trigonometry, which is similar to something called right triangle trigonometry. And anytime you're talking about trigonometry, you're dealing with the words sine, cosine, and tangent. So an important question is, what does it mean when I say something like sine 37 equals 0.6? Like, what does that even mean? Well, what it means is that if you have a triangle, a right triangle with a 37-degree angle, the side opposite the 37-degree angle is going to be 0.6. So we have this back, sine of 37 equals 0.6 approximately. That means that someone figured out that this side will be 0.6 times the hypotenuse. So, for example, if the hypotenuse was 10, the opposite side would be 6. And that's what it means to say sine 37 is 0.6. Another way of saying that is that if I divide the opposite length of the opposite side by the hypotenuse, opposite over hypotenuse, otherwise known as the ratio of the opposites of the hypotenuse, is going to be 0.6. But I like to think of it almost like a percent. The fact that sine 37 is 60% means that in a triangle that's 37 degrees and 90 degrees, the side opposite the 37-degree angle, which is going to be smaller than the hypotenuse, and it's going to be actually 60% of the hypotenuse. So, if this is 10, this is 6, and if this is 5, this thing would be 3, 60%. There's also a concept called cosine. And cosine of 37 is 0.8. Cosine tells you the ratio between the adjacent and the hypotenuse, or I'll just say 80%. The adjacent is 80% as big as the hypotenuse in a 37-90 triangle. So this would be 8. This would be 4. And if this, in this little tiny triangle, if the hypotenuse is 1, this will be 0.6, and this will be 0.8. Or they'll literally be, the opposite side will be sine 37. This is like inches, sine 37 inches. And the adjacent will be cosine 37 inches. In general, here are two good relationships. If the hypotenuse is r and this angle is theta, then the opposite side is r sine theta. Remember, sine theta is like percent, and the adjacent is r cosine theta. In the special case where the hypotenuse is 1, these lengths will actually be sine theta and cosine theta. And here's a question where the hypotenuse is 50, so the opposite side is going to be 50 times sine 37, which is 50 times 0.6, which is 30. Now, right triangle, so if we have a trig table that has all the values for sine and cosine, we're able to answer questions like this, if we need to know this side or this side. But what if the angle is bigger than 90 degrees? Well, for that we need a more general definition of sine and cosine, which is based on, and we'll agree with our opposite over adjacent or opposite over hypotenuse definition with the right triangle trigonometry. And that's when we get into what's called unit circle trigonometry. And the way this works is I have this, here I have a circle with radius 1. This whole thing is, this whole radius is 1. It's kind of hard to see, it's a little small, but these are all tenths. And I also have, hard to see, but around the circumference of the circle, I have these dots. Each one represents sort of 10 degrees around the circle, so there's 36 dots altogether, making 360 degrees. And so over here, approximately 10, 20, 30, 30, I have the dot, which would be the 37 degree point. Now the coordinates of this point, every point has an x-coordinate and a y-coordinate. Well, what those coordinates are, if I were to draw this right triangle, this would be 37. That's better. So here's 10, 20, 30, so 37 is around here. Now if I draw this right triangle here, this is hypotenuse 1, so this is the situation where the opposite side is sine 37 and the adjacent side is cosine 37. But the opposite and adjacent are also the coordinates of this point. So this point is cosine 37 is the x-coordinate and sine 37 is the y-coordinate, which is 0.8, 0.6. Now if I have some other angle, like let's say I want to know what sine of 50 degrees is, 10, 20, 30, I can take this point here, which is the 50 degree point, and if I could approximate the y-coordinate of this point, that will be what sine 50 is, and the x-coordinate of this point will be what cosine of 50 is. Here's 10, 20, 30, here's 40 degrees. And if I want to know, like here, what is sine 40? Well, sine 40 is the y-coordinate, and as we can see, it's somewhere like, if I go to the left there, we can see that it's about 0.65. Now the benefit of the unit circle is that we can go beyond 90 degrees now. So if I want to know, for instance, what sine of 250 degrees is, I go around, here's 180, 190, 200, 210, 20, 30, 40. Here's the 250 degree mark. And the coordinates of this point are going to be cosine 250, comma, sine 250. So if I want to know what sine of 250 is, it's just what's the y-coordinate of this point. So we can see it's down. I go this way for sine, and I see that it's about negative 0.95. If I want to know what cosine of 145 is, I go over here. Here's 90, 100, 110, 20, 30, 40. Here's 145 degrees. For this one, I want the x-coordinate. And notice that the x-coordinate is going to be negative. And that's why cosine of 145 is about negative 0.8. Now, I could also go in the other direction. Yeah, if I get an equation like sine x equals 0.4, that's asking, are there any points on the unit circle who have a y-coordinate of 0.4? So if I go over to 0.1, 2, 3, 4 and make like a vertical line here, I see that it crosses the circle twice. And that's why there's two answers to this question. Oops, just realized 0.4 is the y-coordinate if I'm trying to get sine x equals 0.4, so I have to go up 1, 2, 3, 4 on the y-axis. And these are the two answers. And notice that those are somewhere between 20 and 30, so about 25 degrees. And there's one over here at about 155 degrees. If I want to know when is cosine equal to negative 0.3, I can go over to negative 0.3. I'm looking for the x-coordinate to be negative 0.3, so there's going to be two answers to that. And this one's at about 110 degrees, and this one's at about 250 degrees. Okay, so those are the basics of a review of right triangle trigonometry, specifically sine and cosine, and of how the unit circle allows us to get sine and cosine of angles including angles bigger than 90 degrees.